Hello Cloud Pedagogians, welcome back to the course. In the last session, we got to know about the load balancer, which takes care of health checks and distributing the load across each server. In this session, let's get a quick overview of elastic load balancers from an AWS. So, what is a load balancer exactly? Load balancer refers to the process of distributing tasks across a set of resources. In the case of student directory application, the resources are EC2 instances that host the application, and the tasks are the different requests being sent. It's time to distribute the requests across all the servers hosting the application using a load balancer. To do this, you first need to enable the load balancer to take all of the traffic and redirect it to the backend servers based on an algorithm. The most popular algorithm is round robin, which sends the traffic to each server one after the other. But don't worry, you don't need to know in depth of this algorithm. A typical request for the application would start from the browser of the client. It sends to a load balancer, then it sends to one of the EC2 instances that host the application. The return traffic would go back through the load balancer and back to the client browser. Thus, the load balancer is directly in the path of the traffic. Although it is possible to install your own software load balancing solutions on EC2 instances, AWS provides a service for that called Elastic Load Balancer. In case of our student directory application, now that we have multiple EC2 instances hosting our application in public subnets, it is the time to distribute our requests across our servers using the Elastic Load Balancing or ELB service. Next, we'll see what are the features of Elastic Load Balancers. The ELB provides a major advantage over using your own solution to do load balancing, in that you don't need to manage or operate it. It can distribute incoming application traffic across EC2 instances as well as containers, IP addresses, and AWS Lambda functions too. The fact that ELB can load balance to IP addresses, it means that it can work in a hybrid mode as well, where it also load balances to on-premises servers. As we have already mentioned, ELB is highly available. The only option you have to ensure is that the load balancer is deployed across multiple availability zones. In terms of scalability, ELB automatically scales to meet the demand of the incoming traffic. It handles the incoming traffic and sends it to your backend application. In the student directory application, now if we are looking at the architecture, the ELB looks like one thing. It looks like a single point of failure. But ELB is actually by design a highly available and automatically scalable service, much like S3 service. What that means is that the ELB is a regional service, so you don't have to worry about maintaining nodes in each availability zone or having to configure high availability yourself. AWS maintains that for you. The Elastic Load Balancer is designed to handle additional throughput and will automatically scale up to handle the traffic coming in without you having to configure that feature. The next thing is, how do you check the health of your application? Taking the time to define an appropriate health check is obviously critical. Only verifying the port of an application is open doesn't mean that the application is working. It also doesn't mean that simply making a call to the home page of an application is the right way either. For example, the student directory application depends on database and S3. The health check should be validated all of those elements. One way to do that would be to create a monitoring web page like /monitor that will make a call to the database to ensure it can connect and get data and make a call to S3. Then you point the health check on the load balancer to the /monitor page. After determining the availability of your new EC2 instance, the load balancer starts sending traffic to it. If ELB determines that an EC2 instance is no longer working, it stops sending traffic to it and lets EC2 autoscaling know that. EC2 autoscaling's responsibility is to remove it from the group and replace it with a new EC2 instance. Traffic only sends to the new instance if it passes the health check. In the case of a scale down action, the EC2 autoscaling needs to take due to a scaling policy. It lets ELB know that EC2 instances will be terminated. ELB can prevent EC2 autoscaling from terminating the EC2 instance until all connections to that instance end while preventing any new connections. This feature is called connection draining. That's how you check the health of your application with the load balancers. We'll see the components of the load balancers. The ELB service is made of basically three main components: listeners, target groups, and rules. The first component is a listener. The client connects to the listener. This is often referred to as client side. To define a listener, a port must be provided as well as the protocol depending on the load balancer type. There can be many listeners for a single load balancer. The goal of the listener is to check for requests. For example, since we are routing web traffic and we set up our application to use port 80, we would want our load balancer to listen to port 80 using HTTP protocol. Of course, in my web page, I am using port 8081. We could set up a listener for port 443 using the HTTPS protocol. The second component is a target group. The backend servers or server side is defined one in or more target groups. A target is the type of backend you want to direct traffic to, such as EC2 instances, AWS Lambda functions, or even IP addresses. A target group is simply just a grouping of these backend resources. Each target group needs to have a health check, which is how the load balancer can check the target whether it is healthy or not so that it can start accepting the traffic. The ALB operates on the application layer, which is layer 7 of the OSI model. This gives the load balancer a lot of cool features, and one of those is the third component, which is a rule. The third component is a rule to associate a target group to a listener. A rule must be used for this. Rules are made up of a condition that can be the source IP address of the client and a condition to decide which target group to send that traffic to. A rule defines how your requests are routed to your targets. Each listener has a default rule, and you can optionally define additional rules at your custom level. So if we had two target groups, A and B, we can set up an additional rules that saying if the traffic is coming to our /info page, we can deliver the traffic to target group B. So because of the fact ALB operates on layer 7, you can customize paths for your traffic. So these are the basics of elastic load balancers to start with. In the next session, we will go through the different types of load balancers in AWS. Hope you enjoyed the session and see you again in my next lecture. Until then, take care.